So today we're going to be looking at Chapter 13, the division of polynomials. You can either have long division or synthetic division. We'll talk about the couple of differences and when you can use either one. According to the division algorithm, as you can see, P of x equals D of x times Q of x plus R of x. And you're looking at all those saying, what does all that mean? Well, here we go. The P stands for just the polynomial. So we know the polynomial is equal to D, well, the D, I'm going to do some abbreviation here, stands for the divisor, times Q, well, that's the quotient, and then plus R, that's the remainder. So kind of tight squeeze in there, but that's what each of those things are. Polynomial is equal to the divisor times the quotient plus the remainder. That's just a way that you can write that. And we know that a root or solution of the polynomial, f of x equals 0, is a number r such that f of r equals 0. So what is that telling you? Well, that's telling you that when r equals 0, then we know that we can, when the remainder is 0, then we know that we can have a root. Okay, so when we're doing our division, that's what we're looking to get. If we can get that remainder to be 0, then we can go ahead and we can look at finding factors of a polynomial. Okay, now for synthetic division, as you can see, we can only use it when you have the format of x minus a. We'll talk about that in just a couple minutes. All right, so let's take a look at some examples that we got here. And we'll start with this first one right here. All right, so our goal is to get a remainder of 0 if we can, because then we know it's a factor, and then we can go through and we can talk about what are the factors, and then we can find the zeros of that particular polynomial, which is the ultimate goal. Within the next few days, we're going to be looking at that. Okay, so what I'm going to do is for this first one is I'm going to start off just doing long division, because it'll probably be a little review that we need to do. So x minus 5 is my divisor, and I wanted to divide it into x cubed minus 4x squared plus x minus 2. So the first thing I'm looking for is what times x gives me x to the third power? Well, that's just positive x squared. So I multiply that group by that x minus 5 group by x squared, and I'm going to say, okay, well, that gives me x cubed minus 5x squared. And here's the tricky part for students is you are going to subtract the quantity. So x cubed minus x cubed cancels. Negative 4x squared minus negative 5x squared gives you a positive 1x squared. So please be careful with those negatives. Okay, drop down the x. And again, what times x gives me x squared? Oh, that's just a positive x. So x minus 5 times x gives me x squared minus 5x. Again, I'm going to be subtracting the quantity. So that'll go away. X minus negative 5x gives me a positive 6x. Drop down the negative 2 because I'm not done yet. So what times x gives me 6x? Well, that's a positive 6. If I multiply x minus 5 times positive 6, I get 6x minus 30. Again, you are subtracting the quantity. So 6x is canceled, and this students make the trickiest part, so be careful. Negative 2 minus negative 30 ends up giving a positive 28. And since I can't divide by x minus 5 any further, that is my remainder. All right, so obviously it's not 0 like we wanted, but that's okay. We still get a positive remainder there. So now here's all about how you write your answer. As I talked about in the beginning, right? Sometimes they're going to want your answer in that format. Okay, where you say the polynomial is equal to the divisor times the quotient plus the remainder. So you just got to look carefully. So I can say that my answer is going to be the divisor, x minus 5, times the quotient. The quotient is what you got as your answer up there. So times the quantity of x squared plus x plus 6, and then I can just add the remainder of 28. And so right here, here's the answer that I would get if I were to write it in the format that we listed up above there, okay, that I've underlined a couple times. The other format that I've seen, or you possibly have seen in your class, is they maybe have just done to write down what is the quotient. So x squared plus x plus 6. Here's the thing that students forget, but you're not going to, you remember this. Plus, you can say, well, what's the remainder? Well, it's 28 divided by x minus 5. And this is sometimes the answer that we're going to be looking for. So please make sure you're looking for that. This would be like the quotient plus the remainder over the divisor answer. All right. So it just depends on if the directions are given to you, how you need to write it. Otherwise, this typically is what you'll see as an answer if it's multiple choice or what you want to do for your tests and quizzes. Okay. So make sure you look carefully what's asking for. All right. So that's just a review of long division. Hopefully you remembered that. May have been painstaking for some of you, but remember the biggest thing is that you have this minus the quantity. That's the part that you're going to have to remember to do. Okay. Now, we also said that you can go through, and this is a prime candidate for synthetic division because you had the x minus 5 group there. Okay, we're going to change the color a little bit. All right. So because we have the x minus 5, I can do synthetic with this. Now, if you think about it, if you take x minus 5 and you set equal to 0, well, what comes from that is that x equals 5, and there's different formats for your synthetic division. What I learned back when I was your age is to write that 5, because you would get x equals 5, and that 5 I'm going to put in the box. Like I said, I know there's different formats. I've seen some from different teachers. Do whatever format's familiar with you. I think there are some people that, and I'll try and squeeze it up here, that do 5 and they make it like this. Whatever you want to do, it's fine with me. It's up to you what you're familiar with. But I was just told, okay, put that 5 in the box. Now we're going to take all the integers or the coefficients and the constant. We're going to put them in order. So I'm going to say 1, -4, +1, -2. I'm just going to do some synthetic division right there. I drop down the 1, bring down the first number. I take that number and I multiply whatever number's in the box. So in this case, 1 times 5. And I'm going to put it into the next spot. I'm going to get a 5 there. I add straight down. I get a +1. Again, I'm multiplying by the number in the box. So 1 times 5, it's going to go up here, and I'm going to get a 5 there. I add straight down. I get a 6. I multiply 5 times 6 because that's the number in the box. I get a 30. If I add straight down, I get 28. And that last number is your remainder. And if you look, if you take this information, right, and we started with x to the third, okay, so when we started this, we had x to the third was the given. When you divide, you always deduct 1. So you get x squared. And so when I write this answer, I'm going to say, oh, look, I have x squared plus 1x plus 6. There's my remainder. So I'm going to say that's plus 28 over x minus 5. It's kind of like if I asked you to take, 7 divided by 3, and you say, oh, 3 goes into 7 2 times with the remainder of 1. So you write that as 2 and 1/3, right? Kind of the same idea. So that's kind of what we're doing here. And if you look, you get the exact same answer as you did previously. Somebody saying, well, then why would I spend time doing long division? I wouldn't. An example like this, if you have x minus 5, x is to the first power, then I would definitely just do synthetic division. Okay, so it all just depends on what's given to you, what the divisor is in order to make that decision. All right, so I wouldn't waste time on long division unless you have to, and we'll show you some examples in a minute where you're going to have to do long division. But right now, number 2 is another prime candidate as we're going here to look at a synthetic division because it's x minus a number. In this case, the number is I. So what I'm going to do is I know that my divisor is, if I were to set equal to 0 and solve, I would get x equals I. So that's just going to be the number that I'm going to put, as I call it, in the box. Kind of a little divider right there. Okay. I look again, I get x squared, I get 4x to the first plus a constant. I don't need to worry about any zeros. So I have 1 minus 4, +1. Going to go through, set up my information. I drop the first number. If I multiply, I get I. Now here's the tricky thing. You might be going, well, -4 and I don't really go together. So you're right. I'm just going to add that and say -4 plus I, and that's an entire group. So I got -4 plus I. Now, if I do a little side work over here, okay. So I'm going to take I times the quantity of -4 plus I. So if I distribute in here, I get -4I plus I squared. And if you remember how imaginaries work, if you have a plus I squared, well, that just becomes a -1. So ultimately, if I write this back on the line, I'm going to have negative 4i minus 1. So it's not too tricky. You just got to make sure you keep your stuff lined up and organized really nicely. So if I go here, if I add straight down, the one nice thing is the ones cancel, and I'm left with just negative 4i. And that weird looking number is my remainder. So obviously that's not 0. So it says write your answer. I'm going to write my answer. We'll just use the quotient plus remainder over divisor answer. And again, we started with x squared, right? When we did this, we had x squared. So if I drop it down 1, I'm going to have 1x. You don't need the 1, but you can if you want. Plus the quantity of negative 4 plus I. That's a weird looking constant, but that's what the constant would be. Now you can write this two ways. I always like to just put plus sign here and then write my entire remainder over x minus I. And as ugly as that looks, that is your answer. Now somebody say, well, Mr. Ray, do I have to put the plus sign? Can I just put a minus sign there and bring it down in front? Sure. If you'd want to instead, you could say x plus negative 4 plus I. If you want to do this instead, you could do negative 4i over x minus I, right? Either of those would be perfectly fine. You don't need to do that. I always like to put the plus sign, so remember to do a minus, especially when you have multiple parts in your remainder. It's kind of nice and easy. You just put a plus sign there and put the negative with the remainder part. Okay, so there's a good review of synthetic division for you. Again, it looks ugly with the eye, but let me keep on going. All right, so if you take a look at number 3, here's another prime candidate for synthetic division because you have an x to the first power right there. Here's the tricky thing though. If you look at that x to the 5th, we have a lot of gap in there because really what you have to think of this as is you have to think of this as x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. So we have to take all of those zeros. We got a whole place value when we're doing our synthetic division or long division. Okay, so you need to really be careful with that and identify that first before you set up your information. So x plus 2, so if I set that equal to 0 and solve, I get negative 2. That's the number that goes in my box. And now I got to make sure I put all these in order. Yes, I do need to include all those zeros. So 1, I got 0x4, 0x cubed, 0x squared, 0x minus 1. And that's when we go through. So once you set it up, the synthetic division, just be careful, right? Drop down the 1, I multiply, I add, I multiply, I add straight down, I multiply. I'm always multiplying by the negative 2, right? That's the number that's in the box. So I add straight down, I multiply, I add straight down, I multiply, I add straight down. So if I was very careful, I got negative 33 as my remainder. So I want to put my answer down. And again, when you're looking at this, you have to identify that it start off as x to the 5th. So when I divide by x to the 1st, I'm going to have x to the 4th. So just start there and say, okay, my answer is going to be x to the 4th minus 2x to the 3rd plus 4x squared minus 8x plus 16. There's my constant. And I'm going to say plus a negative 33 over x plus 2. And there is my answer. And again, if you want to put the minus sign right there, right, if you feel better with that, and then just put a positive 33 on the top of the fraction, that's fine. But you don't have to. You can put plus and the negative, and that means the same thing. Kind of like that better, but it's kind of your choice as you write your answer. All right. Let's try another quick synthetic division. So I got x minus 1 there. I look and I see cubed, squared, x to the 1st, and a constant. So I have no zeros to worry about. So I'm going to put 1 in my box, right? That just comes from solving there. Put my numbers in order. I got 1, a 4, a negative 1, a negative 4. So just get going here. Hopefully you've been practicing. You're getting good at it. So we drop down the 1, multiply. So multiply by 1 to get the 1. I add straight down. I multiply to get the 5. Add straight down. I multiply to get the 4. Add straight down. And I got a 0 remainder. Oh, nice. That's looking for a little smiley face there because that's what we wanted. We wanted the remainder to be 0, right? Because when the remainder equals 0, that tells us that x minus 1 is a factor. That's what we're trying to solve, because that'll make a big deal about this in the next few days. So if we can get x minus 1 to be a factor, well, what I need to do is tell this in the directions. If you find a factor, then your goal is to find the rest of the factor and then the roots. So how do we do that? Well, if I take what was left over here, so it was x cubed, so now it becomes x squared plus 5x plus 4. So I know that that is the quotient. That's the remaining answer as I go through after I do my division, right? It's x squared plus 5x plus 4. So what I'm going to do is just factor that further, because if I got one factor, well, and it got 0 as my remainder, what I know then is that I have a remaining polynomial that I could see if I can try and factor. So if I factor this, I'm going to say, oh, that's pretty easy. That's just x plus 4, x plus 1. If I take that original factor that we found, I know that all of these are the factors to that original polynomial that we started with, that original cubic function. And then it says you also got to find the roots. So if I go one step further with this, if I were to basically set each of these equal to 0 and solve, I would get x equals negative 4, x equals negative 1, right? All I'm doing is just taking these and I'm setting them equal to 0. This will help me find the roots, right? So negative 4, negative 1, and positive 1. And those are my roots. So again, if it equals 0, that's awesome. We want to equal 0. When it equals 0, then we know, okay, we can factor further. We can find all the factors of that polynomial, which we did in red right there. And then if we take each group, set equal to 0 and solve, then we can know that we can find the roots of that polynomial, right? That the roots, if you remember, that's where the function crosses the x-axis. Okay, so we found the factors, we found the roots, because we got that equal to 0. Right, that's what we're looking for. Okay, remainder equals 0. All right, so there's the front side, just doing some basic stuff that we have some review. And then if you get the remainder 0, you do have to go further and find the factors and the roots to finish solving the problem. Okay, all right, there's the front side. Let's take a look at the back side. All right, so on the back side, what I'm actually going to do is I'm going to start with number 6. And I'll show you why in just a minute. There is a method to my madness at times. So I'm going to start with number 6. Okay, so I'm going to do long division with this. And so I'm going to say, okay, I have 2x plus 1. I'm going to just divide into 6x squared minus 2x plus 3. Just like we did on the front side, to review, say what times 2x makes 6x squared? Oh, that's just going to be 3x. So 3x times 2x gives me 6x squared. If I multiply 3x times 1, I got a positive 3x. And again, you are subtracting the quantity. So I'm going to do the long division first. I'll show you why in just a second. So if I subtract, I got negative 2x minus 3x gives me negative 5x. Drop down the 3. Now you got to be careful here. What times 2x gives me negative 5x? Well, in order to do that is we're going to say that's negative 5 halves. So please be careful with that. I know some fraction stuff there, but you got to really be careful. So if I take negative 5 halves times 2x, well, that's negative 5x. Negative 5 halves times 1, well, that's negative 5 halves. And again, I'm looking to subtract the quantity. So again, nice things that cancels. 3x minus negative 5 halves, so that's going to be plus 5 halves. If you're like, I got fractions, I got, try and add those together. What may be better is if you change this 3, just remember that's the same thing as 6 halves, right? Common denominator. So 6 halves minus a negative, so plus 5 halves gives me 11 halves. There's my remainder. So I'm just going to write my answer in the format we've been practicing this whole time. And I'm going to say, okay, I have 3x minus 5 halves plus, it's going to look a little weird because it's 11 halves. I know some of you guys are decimal people. Put 5.5. Looks a little weird, decimals and fractions. So I like to put fractions there. Just divided by 2x plus 1. And there's my answer. Okay, so there's the answer I got from using long division. Now let's go to the same problem, but look at synthetic division. And this is why I did that. The tricky part is looking at this 2x plus 1. That's the tricky part, because when you solve it, you're like, oh, if I solve this, right, if I take 2x plus 1, I set equal to 0, I'm going to get that the root comes out to be negative 1/2. So that's the number I put in my box, right? And then you're like, okay, well, I'm going to take the 6, the negative 2, and the 3. You say, all right, well, I start doing my synthetic division. I got a 6 there. If I multiply, well, I got a negative 3. If I add, I got negative 5. And right away, remember we said, if doing synthetic division or long division, you should get the exact same answer. Well, right away, you can tell you're not. Here you got a 6. Here you got a negative 5. We ended up with this, 3x and negative 5 halves as the correct answer. So you can see right away, doing synthetic division over here does not work as we just did it typically as we did before. So this is why sometimes when you have a 2x or some kind of thing like that in the denominator, it might be better just to do long division. But you can still use synthetic division, but there's a couple of things that you really got to be careful of. That negative 1/2, that stays in the box. The first thing you got to look at is you have to actually go through and take this, and because in order to get negative 1/2, you divide it by 2, you have to do the same thing and divide by 2 to all of those coefficients in the beginning problem. So you have to divide by 2 and say, all right, well, that means I'm going to get 3x squared minus 1 plus 3/2. So that's the tricky part that I need to do. Now, some of you right there may be going, Mr. Ray, I can't handle the multiple colors. All right, all right. There you go. Maybe make you feel a little better. Okay, there we go. All right, so if I go there, so that's the tricky part, is that you got to divide by 2 first because you divided by 2 in order to find the number that went in the box. By the divisor, you divided by 2 in order to find it. So that's the idea, is you have to divide by 2, so you must do that to all of the coefficients on top. Now you can go through and do your synthetic division. Drop down the 3, I multiply, right? And then I'm going to go through and I'm going to add. That's a bad looking 3 there. Sorry about that. All right. So now when I add straight down, again, if you do this carefully, you can think of this as negative 2/2 minus 3/2 gives you negative 5/2. When I multiply again, I'm going to get positive 5/4. Now you're going, fractions, I got to add fractions. So you're thinking, okay, 3/2 times 5/4 or plus 5/4. If it helps, change it to common denominators. This is the same thing as 6/4. So now I add, I get 11/4. Now again, this is what makes doing synthetic division a little bit trickier when you have a coefficient in front there, is because we divided by 2 right here. The second thing that we have to do when we want to write our answer is we now have to multiply by 2 to the remainder in order to have our answer. So again, this is what makes this a little bit more challenging when you're doing synthetic division. It's not like it's impossible. It just takes a couple extra steps. So actually, let's finish writing out the problem. So this is still 3x minus 5/2. If you think about 11/4 times 2, well, that's 11/2. And since that's a remainder, I'm going to say I divided by 2x plus 1. And there's my answer. You can see it's the same thing. But again, when you're looking at doing synthetic division with a 2x or some kind of x number in front of that x there, there's 2 things you need to do besides the normal, just synthetic division, is you must make sure that you divide by 2 because you divided by 2 up there. So you divide the numerator all by 2. And then when you're done doing synthetic division, you have to multiply by 2, right? Because do the opposite there, just to the remainder. Okay, so you're only going to do that to the remainder to find your final answer. So long division might be easier in these types of problems. Synthetic division works. Just got to be careful. Got to remember those couple of steps, okay, as you're going through. All right, so we got synthetic division. We got long division. Take a look at number 7. Here's an instance where you have to do long division, right? It's 2y squared in the bottom, so long division is required. So I'm going to go through and say 2y squared minus 3y minus 4. I'm going to divide here by 4y to the 4th minus y cubed. Hopefully you noticed we have 0 y squareds. So hopefully you saw, all right, I got to put in a 0y squared to hold place value. If you caught that, awesome. If you didn't, please be careful for the future. Plus 2y minus 1. So I'm going to say, all right, what times 2y squared gives me 4y to the fourth? Well, that's just going to be a 2y squared. I'm just putting it there because I might run out of room at the end. It doesn't really matter where you put on the top there. I know some teachers are really want a particular spot. As long as on the top, then you know that's going to be in your quotient. So I'm going to say, all right, if I do 2y squared times 2y squared, that gives me the 4y to the fourth, right? That matches. 2y squared times negative 3y, well, that's going to give me negative 6y to the third. And then I'm going to go through and say 2y squared times negative 4 is going to give me negative 8y squared. And I want to subtract the quantity, right? Be careful there. So that cancels. Negative 1 minus negative 6y cubed, right? Negative, we got to be careful with there. I'm going to have 5y to the third. Please be careful with your negative signs. 0 minus a negative 8 gives me a positive 8y squared. Bring down the next one. Okay? So now, what times 2y squared gives me 5, right? I'm always multiplying by here. What times 2y squared gives me 5y cubed? Well, that's going to be another crazy one that we got there. We're going to have 5 halves y. Right? It looks kind of weird, but that's what we got. So let's multiply. All right, so that nice thing is that's going to be 5y cubed. 5 halves times negative 3 gives me negative 15 halves. Got some good fraction work here today for you guys. And then 5 halves times negative 4, well, that's just going to give me negative 20 halves or negative 10y. Subtract the quantity. Disappears, looks good. All right, I got 8 plus 15 halves. Well, if you think about it, 8 is the same as 16 halves. So 16 halves, right, minus a negative, distribute carefully. 16 halves plus 15 halves gives me 31 halves. 2 minus a negative 10, well, that becomes addition when I distribute that negative. So I have plus 12y right there. And then I bring down the negative 1. There we go. Okay. So now what I can do is I got to say what times 2 gives me 31 halves. Well, in order to figure that out, what I want to do, some great fraction work here, is I'm going to say, well, that's 31 fourths. That's some good fraction work that we got going on right here. So if I multiply 31 halves, 31 fourths times negative 3, well, that's negative 93 fourths. And then 31 fourths times 4, well, that's pretty easy because the 4's cancel. And I got negative 31. See, that wasn't so bad, right? Minus the quantity. Cancel. I got 12y minus a negative, because plus 93 fourths. So if it helps, if you realize that 12 is the same as 48 fourths, and because we're distributing the negative, I'm going to add 93 fourths, right? If that helps a little bit. So right off to the side maybe, and then go ahead and add carefully. If I add carefully, I believe I did this right. I got 141 fourths y. And then I got negative 1 minus, right, that just becomes a plus. So I have negative 1 plus 31, going to give me a positive 30, right? And so if I look at all this, because I can't find something times 2y squared to give me 141 fourths, y to the first, this whole part is my remainder. So what I need to do is take my quotient that I had way up there. So I'm going to take, okay, I have, whoops, I'm going to take 2y squared plus 5 halves y plus 31 fourths, right? That's my quotient that I have in there. Plus my remainder was 141 fourths y plus 30. And that whole remainder, remember we divided in the beginning, was 2y squared minus 3y minus 4. And that whole sweet looking answer is what you get for that problem. Okay, so there you go. There's that long division, right? Gets a little more complicated as you're going through when you have the y squared in there to deal with. Okay, number 8. Here's a good one for you to try, right, on your own. If you want to hit a pause right here and then come back and check your answer, please be careful that if you look, there's a lot of zeros up there. Okay, so I'm going to go through and say, all right, I have 2 would be what goes in the box. That comes from solving x minus 2. So now if I go here and I'm going to take that x to the 6th, so I'm going to go through and say 1x to the 5th, or sorry, x to the 6th, 0x to the 5th, 0x to the 4th, 0x cubed, 0x squared, 0x's, minus 64, right? So I'm going to just do some quick synthetic division, right? Hopefully you pause it and come back to check your answer, or work with me, or pause if you need to. Right, here we go. Let's go some super speed, but please be careful. Drop down the 1, multiply, add, multiply, add, multiply, add, multiply, add straight down, multiply, add straight down, multiply, add straight down. Oh, look. That's what we wanted, right? We wanted a 0 as that particular answer. So now, or as a remainder, right? Yay! We got 0 remainder. Okay. Yeah, that's a bad looking. There we go. Let's get rid of that. Okay. Remainder equals 0. That's what we wanted. So again, we start at x to the 6th. So we do our division. We're going to get 1x to the 5th plus 2x to the 4th plus 4x to the 3rd plus 8x squared plus 16x plus 32. And this is our final answer. We don't have to worry about putting a plus 0 remainder, right? That seems kind of silly. So I'm just going to leave my answer like that. I do believe that that is not factorable. Yeah, looking at that, I don't believe that's factorable. If you want to try and see if it's factorable, go ahead, see if you can find if you can factor that, and then please let your teacher know and say, hey, we were able to factor number 8 at the end, and then you will be a superstar like I know you are. Okay? If you got any questions, please ask your teacher, but there is day 1. Good luck.